Hey folks, Quilly here, and welcome to a brand new standalone Unity tutorial. Today we are going to set someone on fire in 2D. Basically, Ludendaire's right around the corner, and I was thinking about previous games that I'd done, and I had a card game that I did where the border of the card had this sort of really cool, sort of glowy, wobbly effect going on, and I in fact did a tutorial for that. It mostly involved some shader work. And I was thinking about it, and I was like, what if you wanted, when you were moving that card around, to sort of leave some of that glow effect behind, especially if it was sort of a fiery kind of effect or something like that. In particular, I was thinking about, could I apply that kind of shader to like a character in like a 2D game, like a platform or something like that, and give them a fire effect. And I realized that just using that shader effect wouldn't really be sufficient because if you wanted the fire to sort of like linger behind as you moved and sort of reacted to the character's movement, you'd really actually want to use a particle system to do that sort of thing. And Unity doesn't have a built-in particle system in the same way that it's got it doesn't have a built-in 2D particle system in the same way that it's got a built-in 3D particle system. Now, you can kind of use both. You can use the 3D one and 2D. There's other things you can do, but really, for the sort of effect I wanted, I thought, you know what? I think I would like to do it myself. In particular, what I think would be handy, because one of the things when you use a particle emitter is it comes out of a particular spot or a volume or something like that. And I think what I would like is if we could get the edge of the graphic to be burning. Could we do something like that? So we're going to give it a go. What I've done here is I've imported in a graphic. What am I looking for? Multiple. I've incorporated or imported in a graphic from OpenGameArt, and we're going to use that as our 2D platformer. Although I just realized this is not going to be transparent, which is kind of vaguely annoying. Ooh, you know what I'm going to have to do? I'll do a quick little crop in the Photoshops. So let me just open this file with Photoshop. Photoshop is here. Bring this in over here. And yeah, what I'm going to do is grab maybe just the standing version. I'm trying to think of what would have some of the coolest sort of edges to work with. I think I'm going to use this running version right over here, actually, because I think it might lead to a little bit more fun. And I'm going to grab this the super duper lazy way here. Bum, 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 bum. Just trying to grab everything that is part of the character art. And we got a little bit of the gray there, so I'm just going to try to trim that out. There we go. Copy, new, paste. Like that. And often it's a good idea to give a little bit of extra space on each side, just to avoid, there's some weird stuff that can happen sometimes if the image goes all the way to the corner. Yeah, I didn't grab that line quite correctly, but that's okay. It's going to be good enough for what we're doing over here. So let me go and just save a new copy of that. Images, we're going to have running character over here. Okay. Now, if I go back to the Unities, there's a new running character in there. Great stuff. Sprite editor, there she is. And I guess I can't auto crop in here. If it was multiple sprite, then I would. But I'm going to go and just bring the borders down. So it is a bit more of a tight crop here. Just to say. All right, apply that. Good, excellent. And then we can drop that character into our scene. And there she is over there. Now, she's kind of fuzzy. And why is that? Well, is it because of the mip-map? It could be the filtering mode as well. Here, we want point filter. There we go. Also, it's probably a good idea for graphics like this to not be compressed. So we'll just use the true color over there. It doesn't make a difference here, but every now and again it can. All right, so we've got the sharpness. So there's a little bit of edge there because I didn't do a very good job cropping it. But let's pretend that this is a well-cropped image. Shut up, it's fine. All right, so we've got a running character in here, and what we can do is we can add a polygon collider 2D to this, and it will try its best to try to crop itself to the borders of the image, but you know, it often doesn't quite do the right job. But that's okay, because what we can do after that is we can go into edit collider mode, and we can actually just sort of drag these edges to be a little bit more accurate. The other thing you can do is you can hold Control to cut out an edge, and also to cut out a vertice. Also, if you're on an edge, you can actually just click without holding Control or anything like that to create a new point. I don't know if we'll need to do that. We'll see. You can see the internal shape of the polygon for this gets changed as you go. We'll try to be, it doesn't have to be super precise for this. Although, the more precise, I think, the better our fire effect will be. Now, obviously, you're going to have these sorts of collision boxes for your character, just for hitboxes, for platforming, for all kinds of things. However, the collision box that you use for your fire effect that we're going to do here may not, in fact, be the same collision box that you use for the rest of your game, which is totally okay. You can make that work, and the way you can make that work is... grab you, grab you, grab you. Okay, so let's say what we're going to do with our character here, we're going to make, inside of this character, we're going to create a new empty, and we'll call this like the fire particle effect. Okay, inside of our character. And what you can do is this polygon collider, we're going to copy this component. I'm going to go and paste it on this layer, which you do from here, paste component as new, keeps all the settings. And in your base character here, we could get rid of this 2D collider, and we could do something like add a box collider 2D instead. Yeah, you'll see both colliders in effect, but, whoops, edit collider, there we are. Oh, come on, don't be a pain in the butt. Edit collider. Oh, can I not? Oh, no, there we go. I was going to say, I'm pretty sure I can drag these. I just have to be a little bit more precise, and there was no little hover effect, right? So you might do something like have a standardized box collider for your character that doesn't change no matter what kind of animation your character is doing. You just have a sort of generic form or something like that, and then you could have the effect that was tuned a little bit closer. Anyway, we're not going to get into like doing 3D character stuff in here. For the close-up version, you probably don't want it to be physics, so you could just make it as a trigger or something. We're not going to get into those. We're just happy at this point that we've got a good sort of polygon collider around our character that's going to fit the edges relatively well. All right, so that is part one of our little job over here. We've got that. Part two is going to be to create our particle system. Now, I did go and make a little graphic here for my fire particle. This is just in Photoshop. I just used a brush and went like that, with the softest sort of brush there is. So it's just, it's just a very soft little round blob over here. It's not even perfectly centered, but it's good enough. So we're going to use this as our base fire particle, which is going to be really easy to do, right? We can take the color for this and we can say, make it, well, I guess we could use red for most of it, right? Red like this, and we could even make a variant here, which will be the yellow part and the hottest part of the fire. And we'd probably want to say shrink this down, right? So you shrink it down a little smaller, like that, for the hottest part of the fire. And we'll use these as a basis for our particles in some fashion like this. So let me actually name these. So this is going to be fire particle red and fire particle yellow. And yeah, so the advantage of using just a white dot is that you can tint it inside of Unity to get all kinds of different effects. And that's really wonderful and great and stuff. Okay. So we're going to start with this sort of idea. And in fact, we're going to have two particle systems on our character. For now, though, I'm going to start with I'm going to make our sort of very, very simple 2D particle system. So, in fact, all these graphics are way too big. I think I'm going to drop them like... I suppose I could define the particle size in the emitter. Right, if you got a 3D particle and you just use the regular particles emitter, you can do a lot of tuning there as opposed to just spawning prefabs. But I think it's probably okay if we just spawn the prefabs. Right, so let's say we brought the red one down by half and the yellow bit even smaller. Yeah, okay, we'll go with something like that. I'm going to go and make some prefabs over here. Folder for prefabs. Just try to keep the project neat. It's going to be a very small project, but that's going to be okay. Grab these two. Oh, do you have to do one at a time? Really? Oh, that's a little bit disappointing, but I guess it's fine and kind of makes sense. Let's make sure to drag that in the right place. Okay, so we've got our prefabs, which is good. We can get rid of these particles from inside the game. That's going to be fine. So let me make, at this point, on the fire particle effect, I'm going to make a script, which I guess I'm going to call the fire particle effect. That seems fine. Fire particle effect, like this. Okay, and then you just wait for Unity to compile it. There you go. It starts to respond. And what I'm going to do is drop that on there. Okay, so now we've got the script in place, and we're going to have MonoDevelop open up right there for us. Excellent. Okay, let me embiggen this so you guys can actually see what's going on. Good. All right, so I think for this, we're going to end up having two of these scripts on here, which is totally allowed. right? I can have two instances on this because what I can do is we can put in a public game object, and we can call this the particle prefab, like that, save it. And then in our object over here, we can have one of them do the red blob and one of them do the yellow blob. Excellent. All right, so we've got that effect on there. Now, what we're going to do is we're going to simply pop out a particle. I guess we're going to have some sort of rate. We should probably have something like that. Let's do a... I'll make it public later, but for now, I'll just make it a float called just rate, which is going to start at something like, I don't know, 10 particles per second. Okay? Per second. So every second will spawn 10 particles, which means what we need is something like, we need to keep total track of time, or time since last particle, or something of that nature. Well, I guess I'll have a float. I'll call it, this will be private, or protected. Protected's fine. This is going to be called time since last spawn. Okay, time since last spawn, which, I mean, this would set to 0, but we'll explicitly set it to 0 regardless. And so then what we're going to do is time since last spawn. We're going to, every frame, add the delta time. And then say something like, while, and I'll tell you why it's a while in a second. Or I'll start with an if. If time since last spawn is greater than 1 divided by rate, because this is how many per second we're supposed to do, right? So if our rate is 10, then we should spawning something every 10th of a second, right? So 1 divided by 10 is 1/10. So if time since last spawn is greater than 0.1, or a tenth of a second, then time to spawn a particle. Now, the reason I'm doing, and then in theory what you could do is do time, then go time since last spawn equals 0. What I'm going to do instead, though, is say this, because it's possible if our time.delta time was really delayed, or if we're supposed to spawn a lot, like let's say we're supposed to spawn 1,000, right? It's possible that our ticks are coming in too slow for the correct rate. So what we're going to do is, instead of setting time since last spawn to 0, we're going to just subtract the actual, this is the correct delay between spawns, right? I guess I could do something like this. Float correct time between spawns is supposed to be equal to this, right? And then we can compare that. And then we just subtract that, and we just say here, while. Because that way, if for some reason time since last spawn ends up being a lot higher than correct time between spawns, we might spawn more than 1 particle in a single frame, which will be fine. So, yeah, there we go, something like that. So to actually spawn the particle, we know how to do that. You would go instantiate, and we would instantiate the particle prefab. Particle prefab. And it's going to want a position. For now, what we're going to do is I'm going to spawn it at my like this object, which is to say my fire particle effect. This particle effect position. Plus, I'm going to do something like vector2 dot right, like that. So we're going to spawn it like 1 unit to the right of where we are. That way we'll actually be able to see what's going on right now. We'll of course move this more later on, but for now we're just going to spawn things just slightly to the right, so we'll actually see that it happens. Now, you do need to put in a rotation if you're going to do that, so we'll just make sure it's got quaternion.identity. It doesn't have to spawn with any particular rotation for this effect. Maybe we'll want to randomize it or do something like that, but there's no need to do anything of that sort. And then finally, this can accept a parent, so we're actually going to go and put ourselves as the parent of this new object. That way we keep our hierarchy nice and clean. And there's no reason for us to have to like capture or copy this object or anything like that. That's going to be fine. Probably. Yeah, that's going to be all right for now. So if we go over here, oh, call is ambiguous. Oh, because it's actually a vector 2 and vector 3, we'd have to do some casting, so let's do it that way. There we go. If I hit play, we should get a bunch of particles to spawn here. And we do. This list is getting bigger and bigger and bigger. It's just spawning a whole bunch of particles over here. And that's fine. Okay, so that's a start. Although, are these particles spawning with... Yeah, I guess that's about right. They're definitely going to be bigger than we want. So I should probably scale them even further down. Red particle, you're going to actually get quite small. We're going to want them to be tiny. And you will be even a quarter of that size. I think this is going to be a little closer to what we want, except that my yellow was stretched inappropriately. Okay, I think this is going to be a good base for our particles. We'll keep tuning, I'm sure, as we get the effect in there. Now, next thing I think we're going to want to do is have a script on each one of these particles to give them a bit of motion. I realize that if you get a lot of particles, this might start to slow things down, but that's a problem for another time. We'll figure out if we have a problem before we try to solve it, right? There's a fire particle. It is good to like not go out of your way to do things unoptimally, but there is a saying that premature optimization is the root of all evil. Don't just assume that you have to seek out the single most optimized behavior before you know that there's an actual problem, because maybe there's not going to be. So what we're going to do with these fire particles is we're going to give them a little bit of motion. You know what, these things, I think I've just realized. No, we're going to be fine. Yeah. I want to give them a vector2 velocity, which when they spawn, I think we're going to randomize it a little bit. I think our velocity is going to be a new vector2. So I want it to have a little bit of sideways motion and a fair bit more vertical motion than sideways motion. So this is the x component. I'm going to say random.range, and it's really not going to need very much. Something like minus 0.1 to positive 0.1. And then for the vertical speed, the vertical component dot range is going to be something like, say, 0.1f through, well, 0.2f through to 0.4f or something like that. And these things will also have a lifespan. So we're going to have a float lifespan. Both these are going to be, well, this is going to be public. The velocity, maybe we can expose a couple of variables so we can tune this, but in code it's going to be fine. And we'll give this a lifespan. It's not going to be very long, 2 seconds or something like that. Even that might be a little much. So it's capitalized because I'm going to make this a public, but for now we're going to be okay. All right, so then every frame, what we're going to do is simply say this.transform well, I guess I could go translate. At this point, we're going to move ourselves based on velocity times time.delta time, like that. And actually, first thing we're going to do is say lifespan minus equals time.delta time. If lifespan is less than or equal to 0, then it's time for us to destroy our game object, and then we can return right away. Okay, so we have a limited lifespan over here. Actually, because of reasons, what I'm going to want to do is do something like this. Lifespan remaining. Actually, we'll make it time alive, which will always start at 0. And what I'm going to do is I'm going to increase our time alive based on a certain amount. And if time alive is greater than or equal to lifespan, then we end things. There we go. That way we don't have to worry about... I think it'll be a little bit more explicit what's going on over here. Okay, so now if we run this, I mean, the speeds may not be any good, but if we spawn this, there we go. So now we've got a bit of a particle effect, and things are dying off and everything like that. Yeah, the yellow is going to have to be tuned a little bit. And again, we could have scripts on the emitter. I think what we're going to do is we're just going to go and expose, have a public public vector2 max velocity. Yeah, maybe a max and a min. Which we're going to instantiate to something like new, vector 2. And I think that speed, well, I don't know if the speed was too much. No, it definitely was. So we'll say the maximum is going to be 0.05f and maybe 0.2f in the y. And the minimum is going to be negative and 0.1. Actually, I'm going to write it this way because it's going to be a little bit... So yeah, it'll range from negative 0.05 to positive 0.05 in the x direction, and from 0.1 to 0.2 in the y direction. And then we'll feed that in here. So we'll say our random range is going to be min velocity dot x to max velocity dot x, and then the same thing, but for the y, like this. All right, so if we've got that, this is the easy part too. So we've got this. Might still be going a little on the quick side, isn't it? I don't know. Oh, I am zoomed in pretty close. Yeah, I really don't want it to move much. I really barely want them to move. It's like relative to their size. So let's cut this down even more dramatically. Even more dramatically. Oh, it should be changing them both at the same time. What do I have here? Right. This and that and that. Oh, I just changed the Y to be a lot more, didn't I? Yes, I did. I think I want leading zeros in front of these. Yes, I do. Boom and boom. There you go, with both of them selected. Yeah, that's a lot more what I'm looking for. That's a lot closer to what I'm looking for. I also, now it's time to make the lifespans public. I suppose I could have kept the speed up a little higher, but shrunk their lifespan a little bit. Yellow's lifespan is going to be shorter. So we'll still be making a lot of changes to this later on, but this is kind of sort of how I want to start with the fire effect. Now, one of the things you'll notice here is that there is some funky blinking going on. And why is that? Well, it's because right now in the center of our images here, they're mostly kind of sort of fully opaque over here. And so when the red ones spawn, they overlap and cover the yellow, which isn't what we want. Now, there are a few different ways of doing that. One of the easiest ways to do that is just to go and change the rendering order and make the yellow pixels or the yellow particles always be in front of the reds. So that's one part of things. The other thing I'm going to do is I'm going to take our camera over here, and I'm just going to like zoom in a little bit by making the camera size lower. Something more like that. There you go. All right, so we're starting to get there. There's tons and tons of tuning you can do to something like this, but this is not actually where I want to spend all of our effort today. Instead, I want our effort to be having this effect be applied all over on our character. The other reason I don't want to spend too much effort on the fire particle aspect is because you don't always want a fire effect, for example. And finally, the other thing is we're definitely going to tune this a bit. I think it would work better if our yellow blob actually started with more alpha, and then maybe wasn't quite as small. But this kind of tuning is really silly because I'm going to be doing some changes to the shader soon. But there we go. That looks kind of flame-like. Not as much super close up, right? But look at the effect over here. That's actually pretty convincing. If that was on top of a torch, that would look pretty good. It'll look even better when we set this to be an additive sprite shader instead. I am going to do another change to the camera. It'll look a lot nicer, I think, if we're on a black background, especially to get the flame effect to be quite convincing. Ooh, very nice. Okay. So that's one thing. You know what? The shader change is going to take 2 seconds. So we're going to go ahead and do that. Now, I want to make a change to the shader that is used to render these sprites, which by default is this sprites.default material, right? Sprites.default. A material is just Unity's glue between around a shader, or it's a wrapper around a shader, really. Shader is a piece of code that tells the video card how to render graphics on the screen, how to take a series of vectors and to take a image texture and to take a color and how to factor in shadows and lighting and so on and so forth, and turn that into pixels on the screen. That's what a shader is. A material is just a wrapper that Unity uses around a shader just to make it a little easier for us to work with. I would like to make a change to the sprite shader to use an additive shading effect instead. And the reason for that is that this fire effect won't look quite right if we had any sort of real background. I wonder if I can get something like that quite easy here. Let me think. Let's see. Bear with me 1 minute here. What is this image? So I'm just going to the excellent Kini NL graphic pack to see if I can find, oh, these are semi-transparent, but that's not what I'm looking for. If I can find a good background tile, like something like this, I suppose. Yeah, okay, that'll do. So sort of a gray rock background. So let me bring that into our game here. Castle Center. Then what do I want to do? I can bring it in here. But I can't tile by default. Add a sorting layer here called background. That way it won't hide things. And then the castle center will go to the background layer. I guess what I can do is just make this bigger. Well, if I go and duplicate it and put it here. What? Oh, it's because it's not. Right, of course. This image is an image that is 70 by 70. So we will say that this image describes, it's 70 pixels per unit. So if I do that, it'll blow up. Excellent. And then I can duplicate it again and send this one a little further this way. And then I'm going to duplicate all these guys and send them upwards by 1. There we go. So now we have a little area to play with, and that feels a little bit better. I'm going to make I'm going to select all these and then make an empty. Oh, that's not what I expected. I want to make an empty and then put everything inside. I thought it might group that way, but I'm thinking about how Photoshop works with layers. So I'm just going to call this whole thing background. Then I'm going to take it and just move it a little more like this. Okay, so if we hit play on this, now the flame effect is okay. Actually, it's surprisingly okay. But for things like this, it's often a lot better with an additive filter. Especially if we were to bring down the alpha on all these. Actually, that would make it a lot more obvious. Let's say I brought the alpha down here to there. And for the yellow, we'll bring it down to about there. And hit that. There we go. Okay. So now I don't know if it's that obvious to you guys, but by default, when you alpha blend, because it makes sense, right? Fire should not be opaque. You should be able to see through the fire. By default, alpha blending will average out effectively. It's not actually an average. It's based on the alpha of the image, but it will sort of just blend the two together in a way that's maybe a little bit blah, right? It ends up being sort of soft and muddy, you know, and it's not really the fire effect. Now, you can keep tuning the alphas, and we might, but one of the most powerful things we can do for, I think, a fire effect is to change it to be additive, where instead of blending the two colors, the background color and its own particle together, instead it adds, and that way things will always tend to become brighter and brighter and brighter. So what we can do for that is we want to make our own version of the default sprite material here, sprites.default. Now, creating a shader we know is as easy as going create and then picking a shader over here And then you've got a few different types you can start with. The problem is if you start with this, these are shaders that are meant to be, well, for specific purposes, but, you know, especially like standard surface shader, for example, would just be for normal 3D materials, things that get lit, things that get shadows, things like that. I mean, you can go with unlit, which is sort of what a sprite shader is, but a sprite shader actually has some special code in there to make 2D sprites work the way you kind of want it. The user interface has a custom shader like that too. And what we want to do is we want to be able to get at that code and make tweaks to it. We want to take the existing shader and just make a slight modification. So the way to do that is if you Google Unity shader download, it'll bring you to a page that is the Unity's, like, it's an archive. You can actually download any previous version of Unity that they've ever put out, as well as get a download that just has all of the shaders in it. Okay, this is just the download you get, built-in shaders, and in default resources extra, in here down below, you've got sprites.default. This is the actual default shader for sprites, the same one that gets used right now. What I'm going to do is I'm going to take this, I'm going to drag it into our project over here. All right, and I'm going to call this one sprite-additive. Okay, this is just the file name. If we double click on this, it'll open in MonoDevelop. And we're going to change this to sprites/additive over here. Okay, just renaming it. And then what'll happen is if we look at our fire particles red, and we look at the material over here, actually that's right, we need to create a material. So we've got a shader, we also need to create a material. You can call it whatever you want, but we may as well call it the same thing, right? And we're just going to say that this material is going to use the shader from sprites additive. That's our new one, sprites additive over here. So I'm going to do that, and then I'm going to tell our fire particles red to use sprites additive, which is our new one, and particles yellow to use sprites.additive. Now at this point, nothing has changed, right? If I hit play, we'll get exactly the same behavior as before. But we can now make changes to this shader over here. Now, shader stuff is quite different from, you know, your regular C# programming, anything like that. Some of the syntax looks relatively similar, and it's not that hard to just make a change, but to write stuff from scratch can be quite tricky because the shader is expecting things to be in a particular format and to interact in a few different ways. Luckily, there's very, very, very little that we actually have to modify to get this to work the way that we want. In particular, I believe the only thing we need to do, and I'm not sure about this, we'll find out, is change this line over here. This line over here determines how images get blended together if there's alpha. Okay, and the way to read this is this first value is how much of the color from this code over here gets used. Okay, and it's multiplied. So we're multiplying by 1, which means we're using 100% of the value from here. Okay, and then the second part is how much of the currently existing image that we're going to use, i.e. the background image that we're going to use. And here the value would be 1 minus the source alpha. Source is what we're producing now. So basically, if we have an image, if we're trying to draw a sprite that's got, say, 10% alpha, so it's only 10% opaque, right? 100% alpha, or 1.0 alpha, would be fully opaque, draw it completely. An alpha of 0 would be completely transparent and invisible. So let's say we had a 10% alpha, 0.1. So 1 minus 0.1 leaves 0.9. So whatever the background was, we're going to use 90% of it, and then we're going to add those two together. We're going to use the full sprite that we're drawing, but this doesn't include alpha information at this point, I believe, right? This alpha over here, see, this is the code that draws our current sprite onto the screen. We're taking the color of the sprite and multiplying it by the alpha of the sprite. So the sprite we're drawing is already being dimmed by its own alpha. And then whatever is left over from that alpha, we're going to blend it with the background. So that is the normal way of doing blending. We, however, are going to use additive, where what we're going to do, instead of fading the background, we're going to leave the whole background there. We're just going to use 1 for now, and we'll see how that works out for us. And then we are going to see if that results in something that's quite a bit brighter and more fire-like. And it should, in fact, be considerably so. There we go. Now, do you get the sense? I mean, it's still very, very transparent, but does it not feel so much more glowy now? It's considerably more glowy. And then if we go and let's say we bring some of this alpha back up at this point. Oh, is that only going to take? Oh, because I'm just modifying the prefab. Right. Right. Do I want to... I mean, this isn't right. I don't want to do this. Do I want to multiply? No, because that will tend towards darker. It's because the background is so bright. Yeah, hold on, I know what we're going to do. We're going to overkill the contribution of color from this object. That's what we're going to do. I think what I'm going to do is like multiply this by like 2 or something like that. So I can do something like return double the contribution from our fire color. How do I like them apples? Oh, also. Oh, it's not fading the color either. It's not, okay. So it is multiplying by its alpha here, but that's not actually factoring to the transparency, so we're not getting the drop off. I may... I need to bring up, where's my list of, there it is. I've got a tab open with all the possible like blend operations here. If we were to put this back in, of course the copy and paste breaks constantly because it's mono develop. So if I do that, then we got our alpha blending back in. Which is important for the edge. We're still multiplying the inside by 2. How do I get the glow effect that I want? Maybe I'll just move on. I'm not stressed about this right now. Huh. Just out of curiosity. The background were darker. I mean, I guess it's fine. We're going to want to do something additive at some point, but for now, I'm going to go back to, no, because we still need the outline. I'm going to get rid of the ×2. I mean, it's certainly blending the middle parts together better, and that's nice. Especially if I make the yellow, like, nowhere near as alpha'd out. Alright, well, not quite that bright. Oh, the other thing is there could be something about the layering order that I've got going on here. Alright, you know what? That's relatively okay. I don't know. We'll probably take another crack at it later to get a sort of good fiery glow effect that we're looking for. But for now, that's going to be okay. All right, let's get back to the main matter at hand, which is to get the fire to render as an outline around our character, which we don't have right now, right? And the reason for that is in our fire particles effect, we are spawning the character or the fire just to the right of our current object, right? Which we don't want. Instead, what I want is I want to spawn it based on the path that we've got going on. So let's figure out how to do that, right? We're going to pick a random spot to spawn it at. So instead of like overwhelming the update, I'm going to make a subfunction over here called spawn fire along outline. So this thing's job is to spawn a single instance of the fire. And how do we find our outline? Well, we have a poly collider 2D on our object, and we can get that. We can get component polygon collider 2D. All right, we know that this is attached to the object that we've got going on here. Where's our character? Fire particle effect has a 2D collider on it. We want to spawn the fire along here. In fact, later on, we may only want to spawn it on sides that are sort of like the top side as opposed to spawning it along the bottom. Although, you know, it might be perfectly fine going here. So we'll see how it goes. So with the collider 2D, it's got a few different things. It's got paths. One of the things that's a little unintuitive about this collider is it can actually be made up of multiple polygons, because you could have an image that has multiple little chunks, and each one can have its own little polygon around it. So as a result, the polygon collider has a list of points separated into paths. This collider version, this one that we've drawn, happens to just have a single path over here with a list of elements. Every single one of these points is an element in the path in order. And I think it'll be clockwise or counterclockwise, I'm not sure. But it'll have every single one of these points will be one of these elements. But you could have multiple paths. So what you're actually going to want to do is pick one of those paths and then pick a, let's say for now, a point in one of those paths and spawn the object there. So we're going to say, so it's got a path count, right? So we want to go with a int path ID is equal to random.range 0 to the collider's path count. Random.range, when you use integers, will return a number that is less than the second number, which is good because if because we're looking for an index, right? Path index, in a sense. So let's say there's only one path, so a random number from 0 to 1, then in this case it would always return the number 0, which is correct because the first item in the list has an index of 0. So now that we've got that, we can get the list of points from the collider. Get path, you pass it an index, and it returns an array of vector 2, which is the points. And for now, what I'm going to do is I'm going to pick a random point. Oops, it's an array. I'm going to pick a random point. Spawn point is equal to random.range from 0 to points.length, like that. And then I'm going to have another function here, spawn fire at position, which is going to take a vector 2, which is going to be the position over here. So we're just going to offload that job. And I need to fix my class here. There we go. So all we're going to do now is say spawn the fire at position, spawn point, like that. Okay, and then in that code over there, we're going to put this instantiation where the position is coming from here. Oops. Is coming from here. I bet you this is local position, but we'll test that. So now over here, when we spawn it, we say spawn fire along outline, like that. Boom. Okay. Keeps the update very simple, and then keeps these things relatively minimal as well for what they're going to do. We're going to make a change here because we're not going to want to spawn right on the points later on. We're going to get this started. Cannot convert int to vector 2. Oh, yes, we want to take the points at this index. There we go. Now, of course, I mean, if this for some reason doesn't have a polygon collider on it, we'll get an error, but we're going to be okay at this point. So let's hit play. So there we go. So now we are randomly spawning fire all over the image. And I want to test. If I move this character, yeah, it's going to keep spawning the fire at the old outline over here. And the reason for that is these points are in local coordinates, so we actually want to say the spawn point plus this dot transform dot position, like that. I'm going to hit, oops, I'm going to hit play. I'm not going to hit play. Because this is a vector 3. That's okay. We can just cast it to a vector 2 so it drops off the Z component. Now if I do this, There we go. It'll keep spawning at the same location. Now notice as I move the character, the fire, even though the fire effect is quite weak right now, the fire moves along with the character. And why is that? Well, because it was quite good that we went and made the fire particles be parented to ourselves to keep our scene organized. But now that means that as I move the parent, all the children move as well. So I'm going to remove the transformation, like the parent assignment. So now the particles are just going to be applied to the root of our world. We may want to have like a single particles parent somewhere off, right? So rather than make the new particles be a child of our fire particle effect script, instead make it a child of something else, just to keep our scene neat, but still make it so that when we move the character, the fire lingers back where it was. Okay, we're going to make a few changes here. What I'm going to do for a fire particle effect is I'm not going to spawn it two kinds of particles. Instead, what I'm going to do is I'm going to make a slight change so that the yellow is inside the red right away, because it was looking really dumb to have them split up separately. So now the yellow is going to be inside of here. I'm going to remove the script from the yellow component. So it's just another image inside of this one, and it still renders on the correct layers. Although, is the blending like way off? Oh, because it's scaled from within as relative to the parent now. There we go. So we want it like half the size of the red. No, that's too much. Let's go back to 20% of its parent. There we go. So let me apply this, remove it from the thing, and then the fire particle effect is only going to spawn these red particles. Because the yellow one, in fact, I'm going to go and delete it. We're never going to use the yellow particle directly. Instead now, the red particles just always have a yellow center. And if I find my character over here and we take you and move you around, there we go, I can drag you this way. There we are. Now, this doesn't look particularly flamey anymore, and that's because our volume of stuff being spawned is too little. So what we're going to do is we're going to tell our fire particle effect, oops, we need to make that public. So our rate over here, because it was fine when it was only spawning one spot, but now it's spawning all over. We're going to make this public, but before I hit save, I'm going to increase the rate to like 500. Okay? So 500 particles per second. That's probably way, way, way too much. Oh, it didn't actually take. Well, I thought it would. It would not serialize it until after. All right, so now it's looking a little bit more flamey. That is true. And if I do move the character around, mostly look at it over here, you know, it follows around. That's quite cool. I think the flame lasts too long, so we need to cut down its lifespan dramatically. So in our red particles over here, the lifespan is going to be like 0.5 seconds, if even that much. We may have to speed up the particles a bit more again. All right, that's not bad. One thing we need to change, though, is, like, if you look here, we don't want the fire to ever be in front of the character. I really want to make it look like more of an outline. Now, still not perfect, because it's spawning at these points, right? Which is not what we're going to want later on, but we're getting closer. So let's do a little bit of a change over here in our 2D renderer, right? It's got these sorting layers. I'm going to add another sorting layer here. There's going to be our characters. And then I'm going to add a fire outline effect. And I'm going to make sure that the fire outline effect is behind the characters at all times. So our running character, its sorting layer is going to be characters. And our fire particles effect, we're going to make sure to tell it that it's the fire outline effect. And now it's going to spawn behind our character. Excellent. And then as I run around, our character is fully visible. Okay, we're getting closer to what I want over here. But now the thing to fix is to not have it show up on these points. So what are we going to do to solve that instead? Well, it's not too hard, because what we can do is we've picked a so we're looking at all the lists and we're finding a spawn point. But what I want to do instead is do something like int spawn or int point index. Okay, we're gonna just store the random number in there, and what I'm going to do is say something like point A is going to be the one taken from point index, and then I want to get a point B, which is going to be the point index plus 1, although we'll have to use a modulus here based on points.length so that it wraps around. So we're going to take 2 points. We're going to take a point, and then we're going to take the next one in the list. And then our actual spawn point is going to be equal to point A plus point B divided by 2. No, not divided by 2. What we're going to do instead is we're going to do a vector2.lerp, okay, which takes 2 vectors, point A and point B, and then we're going to give it a percentage along that vector. T is supposed to be, I don't know, time or whatever, but T is how far. If we have a T of 0, this is going to return A. If we have a T of 1, it's going to return B. If we return a T of 0.5, then it's going to return a point exactly between A and B. So what we're going to do is we're now going to return a random.range from 0f as a float and 1f as a float. So this will return a floating point number instead of an integer. So it can return 0.67 or something like that. So now spawn point will be a random spot between these two areas. So let's go and hit play. Play. There we go. Ooh, index out of range on line 44. Is there an order of operation bug here? There we go. Okay. So now we have a whole glowy, fiery outline. All right. It's getting better. Oh, I don't think I ever applied the change where the yellow particle. No, it is. Feels a little low, but it's probably because of the way that it's adding together here. I'll make the yellow part brighter. All right. We'll still have to do some tuning. Oh, sorting layer. Oh, you were on the default sorting layer. I need you on the fire outline effect sorting layer. There we go, with a order on the layer 1. So now the yellow is going to be too bright. Yeah, okay, good. But it is much more visible again, so we're going to bring it down to around there and see how that goes. I think the yellow needs to be a bit bigger after all. Maybe about half of the red dot. All right, it's getting there. The other thing that we could do is the yellow's alpha could drop over time, because yellower fire is hotter fire. The other thing we could do, instead of having these two things here, we could do some sort of gradient effect or something, but I think it's going to be a little bit easier if we do it this way. So yeah, the yellow particle, I guess what I could do is sort of cheat and say, yeah, I'm going to put a fire particle script back on yellow over here. I'm not going to give it any velocity, so it's going to stay... that's not true. Yeah. I'm not going to give it any velocity, so it'll stay locked to its parent, which is going to be the red fire. And I'm going to give it a lifespan a little shorter than the red. So let's call it 0.3. Now, it's gonna blink out right now, but we're going to do a slightly different fade-out effect going forward. So there's going to be that, and or the red part might actually stick around a little bit longer here. There we go. All right, so we're getting closer. We're getting closer to the sort of thing I'm looking for. It's still not perfect, but like, vroom, the character's running. Maybe we want to leave a fire trail. Maybe we don't. I don't know. But here, this looks cool, right? Definitely, like, we're talking about, this could be used to show that someone's literally on fire, but it could also be used to show that someone's got a power-up going on. Doesn't it look like we've got an uber power-up going on right now? Maybe it's like some sort of bloodlust, or maybe we've picked up double damage, or I don't know what it is. And you start color coding instead of using red and yellow. You know, what does it mean if we use blue or green, maybe? Like, what does that imply? Maybe you know, green is regeneration. Maybe green is being poisoned. It sort of depends on what kind of decisions you do with your effect over here. But it's definitely starting to look a lot better. Actually, I don't think I want the duration this long, actually. I think rather than doing that, I think I actually want the duration to be quite a bit shorter. But maybe give it more speed. For the red bit, I want it to go up a little higher, a little faster. So the velocity here, I'm going to make it go from 5 to, let's say, 0.9. Maybe a little bit more lifespan. Back to 0.5. All right. Now, at this point, I'm like, okay, if I want a more complete outline, there's a couple of things I can do. I could, because it feels like there's all these breaks, which might be okay, might be fine in the effect. I could add more fire effect. I could ensure that there's even distribution along the fire path, but I don't think that's needed. I think this random distribution is perfectly fine. I could spawn more stuff. I think one of the easiest ways is actually just to make my red flame a little bit bigger, which is going to increase a little bit of the overlap between the components. So that's one way of doing it. And maybe I do want more particles, but you have to remember right now I am spawning 500 particles per second. Now, they last half a second, so at any point there's about 250 particles, which isn't bad. I mean, we can definitely simulate that many things. But here's the problem. When you're creating 500, when you're instantiating, right over here, where are we talking about? When we're instantiating 500 game objects per second, and which means, therefore, that... Oh, the lifespan should be randomized a little. Yeah, I'm going to do that. Words. Yes, and so you're instantiating an object 500 times per second. You're also destroying or cleaning up the objects 500 times per second. That leads to a lot of inefficiencies in garbage collection, and what we're going to want to do is use a simple pool. We're going to want to use a pooling system to prevent having to... instantiate and then destroy these objects over and over again. But yeah, the lifespan over here, what I'm going to do at the start is I'm going to set that the lifespan is actually equal to the lifespan times random.range from 0.9f to 1.1f. So it can be 10% shorter or 10% longer than the average. That will just give us a little bit more variety in the flame, and I think a way that's going to be a little bit more interesting. All right, anyway, it's fine enough. Okay, so spawning and instantiating and uninstantiating this many things this quickly is often a really, really bad idea. So what can we do? Well, pooling, the idea with the pooling system is to, instead of destroying an object, you simply disable it. And then when you need a new object, you first check to see, do I already have a copy of this object available that's just disabled, right? Rather than instantiate a new one, what if we just wake up an old one again? Wouldn't that be better? And that's exactly what we're going to do over here. Now, I have gone and created a script called, I call it, what, Simple Pool? Just going to create a blank file over here because it'd be a little easier to copy and paste. But I created this some time ago, and it is available on the GitHub Gist website. Just going to... yes, of course, because copy and paste never works. There we go. Did that actually grab it all? It did. There we go. It's got a reference in here. You can find it there. It stays updated. So this is my simple pool system over here that will do all the work required to prevent actually instantiating and destroying objects for you. And all you have to do to use it is, instead of calling instantiate, call simplepool.spawn, and instead of calling destroy, use simplepool.despawn. That's it. Otherwise, it's exactly the same as doing instantiate. So our fire particle effect, that's what we're going to do. Instead of instantiate, we are going to spawn that particle. And in fire particle, instead of destroying it, we're going to say despawn. That's it. It also does a lot of error checking, so if you use it slightly incorrectly, I mean, it'll spam you in the debug log, but it'll still effectively do the right thing. So now what this is going to do, when a particle expires, instead of being destroyed, it will simply become disabled. Now, there is a bit of a side effect to that. The side effect is when you go and call simplepool.spawn, I mean, the first time, if one doesn't exist, then everything is fine. You get a brand new object. But after it gets despawned and then you call spawn again, it's not a new object. It's an exact duplicate of your previous object, which means any values that you had kicking around are still going to be there. For example, time alive, it's still going to be the old time alive, which means now you have to make sure to reset that. Okay? Otherwise, it's going to remember what was there before. So you need to make sure to reset that. Check any bookkeeping variables you have. have to be reset to some default value. Min and max don't matter because that's not actually a bookkeeping value. Lifespan doesn't have to be modified either. Well, that's interesting, because we're modifying lifespan, and that means every time this runs, and actually start won't run, but we'll get to that in a second, means that every time this runs, lifespan's going to keep moving. So what we I guess what we're going to want is something called actual lifespan, right? I'm going to get rid of this equals 0 just because it would be confusing. And I'm going to set actual lifespan to be 10% higher on low or lower than the lifespan value in here. And that's what we're going to use in our comparison over here. There we go. That way, we never actually change the actual lifespan number, right? These are just going to be properties that are basically set once in the inspector and never change at runtime. These are bookkeeping values that do change at runtime, as does velocity, gets set here based on those values. So now fire particle is going to be completely clean and reset every single time it gets spawned again. Except that it won't, because look at this node over here. I've got that written in there, but it may not be clear. The functions awake and start only ever get called once per object, ever. Once per object, ever. It won't do that. It won't do it again. There is something that does get called every single time we respawn an object, and that is on enable. On enable, this gets run every single time an object goes from being asleep, or it's disabled, to when it becomes enabled. Does awake actually call more than once? I'm not sure. But on enable does. On enable will get run every time you reactivate an object, which means every time spawn gets called on it, as well as the very first time, which sometimes isn't what you want, but in our case is absolutely 100% what we want. There are different timing issues. On enable will actually run before start does, so sometimes you can get some weird conditions that you weren't expecting, but for us this is going to be okay. So now on enable, this will clean up the particle every single time you spawn it. So now if I were to go and hit play, assuming I've done everything right, we should get something that looks exactly the same before. Oh, right. So you see this error over here. It's because I'm still despawning the yellow particle. I put in our code over here, I have the yellow despawning earlier because of the fire particles over here. I'm going to go and remove this. I'm going to remove this component because the yellow was trying to destroy itself. It was trying to despawn, didn't exist, which wouldn't cause a problem. Again, the script handles it all okay, but it means we're spanning our console, which actually slows things down. But now if we run this, we get a script that should be good. You can actually see these guys blink in and out. They go gray for a second as they become disabled until the next one spawns. So we keep reusing the same components, which means we don't get as much garbage collection going on here, which means this should be considerably more optimal. Now, there's probably all kinds of different ways to optimize this. It may, rather than have each fire particle have its own script, it may in fact be better if fire particles effect over here was just looping through all the fire particles every frame. Maybe, maybe not. I'm not sure. I think this is actually going to be very, very, very good. The other thing you can do, by the way, with Simple Pool is you can preload a pool and say, preload like 500 instances of some type of particle, which will be just disabled at the start. I don't think we really need to worry about that. Technically, the first time a fire effect starts, there might be a slightly increased time for it to kick in because it's got to spawn all the fire particles the first time rather than have it preloaded at the start of the level. But really, it's going to be okay. And the system does handle itself completely automated over there, which is great. I still don't like the fact that this stuff is just sitting out here in the main hierarchy, and maybe I would want to clean it up later on, but let's not worry about it for now. So we got our character, can move around, it leaves this little outline as you go, which is kind of sort of neat. I like that. Vroom, vroom. So you're going to want to tune like lifespans and different things like this as a basis of how fast your character is moving and how you want the effect to look and different things like that. But all right, not too shabby right now. Is there anything else I want to do? I mean, you could spend an infinitude tuning these particles to get them to look right, which is really kind of sort of where we are here. Probably Let me trim down on the yellows again. Yeah, I think that's better. You can make these changes to the prefabs at runtime, and it will stay. Oh, it actually doesn't take effect right away. That's interesting. No, that is too small, so call it 0.35. A little bit in the middle. There we go. That's looking a little bit better. I think I, again, may want to make the red bits a little bit bigger. Let's call it 0.2.2. A little bit more blobby. The other thing that might be good is, oh yeah, that's something we can look at, is when you use the 3D particle system, one of the things you can do to the particles is you can have them change color and shape over time, or more likely size over time. Why don't we go ahead and implement something like that? Now, there's two ways we could implement something like that. I could add it as part of the fire particle script over here. But again, remember that yellow doesn't. Well, I guess I could. Okay, here's something I can do. I could put the fire particle script back on yellow over here. But again, the yellow particles, well, in this case, they actually aren't going to destroy themselves because they've got too much of a lifespan. But let's say I make this lifespan shorter than the red. So the red lasts for 0.5. I'll say the yellow lasts for 0.3. Now we're going to go back to having the console log spam out all these errors because yellow's trying to despawn itself too early. And actually, that causes it to destroy itself. What I'm going to do on our fire particles script is I'm going to put a flag on here. Public Boolean destroys self, which is set to true by default. Destroys, spell this correctly, destroys self, set to true by default. And I'm only going to actually destroy or do the despawn over here. Okay? So if destroys self and this, then we despawn. And what I'm going to say for the yellow particle is I'm going to say it doesn't destroy itself. Yellow particle never destroys itself. It's got this lifespan, but when we do hit our lifespan, yellow is not going to do anything. It's just going to pretend that that never happened, okay? So we don't get any errors or anything like that. But the upshot of this is now we can do something like specify, let's say we're going to create an enum, make it a public enum, and we're going to call this one alpha falloff. And we're going to have a value of none or perhaps linear. Okay? So something will become more transparent over time. I like that. So we're going to have this and, you know, to do, consider other falloffs, like square root, question mark. You know, there you go. Exercise to the viewer, different types of falloffs. So then what we're going to do is we're going to have a public alpha falloff. It'll default to none, which is fine. First of all, that's supposed to be spelled this way. Oh, you're not happy because it's defined within the class. What if I define it out here? There you go. You're okay with that. This is a good example of needing a namespace, though. Let's just pretend we don't. Well, actually, why don't I? I don't think that'll cause anything to break. So I'm going to call this the fire particle namespace. And then, does it get confused that it's got a class with the same name? I don't think so. I think that's totally fine. So we'll do this and do that. No complaints that the class is the same as the namespace? Yeah, there you go. This way, if there's anything else in all of Unity and C# that had the name alpha falloff as something, we're locked within our own namespace here, so we don't have to worry about those collisions. So we're going to be okay. Falloffs. There we are. So we've got this and that. So I guess we're going to want a float. These should not be capitalized because they are privates. Actual lifespan. and time alive. And we're going to call this one alpha. And we're going to set the alpha to be equal to 1. I mean, technically it's a float if you want to be clear. So you reset it there. And what we're going to do, because we've set alphas for our color over here, right? Float starting alpha. So what I'm going to do is I'm going to set the starting alpha. Yeah, let me get rid of the alpha thing. So the starting alpha, I'm just going to make sure that we go from, so we need get component sprite renderer dot color dot alpha. So we're going to grab the alpha from the sprite renderer over there. Oh man, but no, it's going to have, oof. How do I want this to work? This is actually going to be the one thing that needs to get cached. Yeah. I'm going to move this to start. Yeah. Okay. Sorry for the confusion. This only runs once, not on every spawn. So when we spawn the very first time, we're going to capture what the correct starting alpha value is of our particle based on what we've set over here, right? I've got my slider set over here. We're going to grab that amount. And then one of the things, what we're going to do is when the particle gets enabled, we're going to make sure that the color C from this, the C.A is set to starting alpha. And then we're going to go and lock that back in there. Boom, like this. We're going to have to reference the sprite renderer a lot. And while they have optimized this a fair bit, let's go ahead and sprite renderer, like this. We don't need to reset this every time. We only need to get this once in the very first spawn. And then we can do that. And then we are... Actually, rather than capturing starting alpha, why don't I capture... That's a good idea. Color, original color. That's what we're going to call this. Or, yeah. So we just grab the original color. And then what we do is we reassign. So the sprite renderer.color, we set it to be original color over here. There we go. Reset the color to the right value. Excellent. Okay, good. Then we're going to want the alpha falloff code. So during the update, you know, we may be destroying ourselves. We'll see. If falloff, which isn't really alpha falloff anymore. No, it's okay. If alpha falloff is equal to alpha falloff dot linear, right? For none, we're not going to do anything. So what we're going to do is, as the particle gets older, it fades out. So we're going to have to figure out what the percentage lifespan is, right? And that is the time alive divided by actual lifespan. Although, I guess this is effectively going to be the alpha. It's going to be 1.0 minus this. I'm going to put parentheses for clarity, even though the rules operation would be okay. So when the particle is brand new, time alive is 0. So this will return 0, which means it's going to be 1 minus 0, which means 1. So we've got a full alpha. Now, we're not actually going to set ourselves to full alpha. What we're going to do is new color is going to be equal to original color, original color, and the new color's alpha is going to be multiplied by this alpha value. Because that way, if our original color was like 0.5 alpha, we don't want to immediately on the first frame set it to an alpha of 1. but we do want to use 100% of the original alpha, and then we want to fade off based on that. So then we can go sprite renderer dot color is equal to new color, like that. So this will fade out over time. I'm going to make sure that this is clamped. Math f dot clamp. Clamp 0, 1 is a shortcut to ensure that it just stays between 0 and 1, so you don't actually specify. So this will make sure that alpha is always between 0 and 1. It'll never go negative or above 1, which normally wouldn't matter, but a value of here greater than 1 would actually potentially mess things up over here. So I don't know why that would happen, but let's make sure that's okay. So now we're going to say for both of our particles here is I'm going to tell them that they have a linear fall off, which is why for a yellow particle, even though it doesn't destroy itself, the lifespan is important, because once it has been around for 0.3 seconds, it'll actually be fully transparent. It won't be destroyed, but it won't be visible. So let's do something like this. Don't pause, do this instead. What? I did something bad. At 25. Oh, here's what's going on here. It's a timing thing. Start runs after on enable. I think I actually want this to be awake. If I recall correctly, awake runs very, very first. But yeah, in on enable, we're trying to reference sprite renderer, which didn't exist yet. I mean, there's things we could do, but I think if I switch this to an awake, let's clear this, hit play. There we go. Awake runs first. Start runs right before the very first time update gets called. Start, it's a little bit deceptive, but start is actually one of the last things that ever gets called on your character. So these things should be fading to 0. Oh, and we can actually see it. We can see the alpha drop down on these particles over here. Now, I'm not convinced the linear fall-off is really giving us what we want, but I guess one of the things we could do to see it maybe a little bit more clearly is give us, I'm going to give us a ton more vertical speed, which will just give us a little bit more separation here. Oh yeah, things are definitely fading off. See that? Look at that. And actually, that is an even better fire effect than before. Good. And I think what I'm going to do is the yellow bits, I'm going to go and shorten its lifespan dramatically. All right, that's probably too short. Ooh. Ooh, I like it. Yeah, that's pretty good. Vroom. Oh yeah, that fade effect is good. I suspect that linear fall off is not what we want in the end to do something like that. Should we go and implement another one? Sure. Let's make one that's called like square root. I don't know if this is exactly going to be the correct name, but it's going to be something that works kind of like that. So else if it's the square root. So let me think here. Google can graph things for me, can't it? So the square root. So let's get this initial alpha, and then what we're going to do is we're actually going to say that we're going to be using the mathf.square root. Now, square root is not a very fast operation, so this actually might not be very performant. Although I suppose we could like pre-calculate some sort of array or something like that, so we didn't have to. I don't know. It's fine. So if we do this, when the alpha is 1, we'll have a 1. If it's a 0, it'll be a 0. Obviously, that's fine. We're going to go from... It goes slowly at first, right? Yeah, as you get closer to 0, the fall off is going to be a lot faster with this function, which is, I think, exactly what we want. Or do we want the inverse? I don't know. Let's see. So with... I'm going to switch to square root. Square root. I mean, maybe one should be squared, the other one should be linear. Yeah, I think with this, it's closer to full brightness longer and then falls off very quickly. I actually think that's the opposite of what we're looking for. I think we're looking for something that falls off more quickly and then sort of lingers. Which I think would be a more accurate description of if we were starting with a value above 0. No. How do we want this? Anyway, math and graphing is annoying and hard, but I'm kind of liking this fire effect, you guys. I'm convinced that with a little bit more work, and that's the thing, working with the fall-offs, I may want to hold off until I'm happier with the shader. Because it's not being additive right now. It's a lie. It's not actually additive. Something like 1-1, I think, would be more additive. Would that lock in right away? It's definitely a lot brighter, but it needs... needs what? Is there a chance if I just change the color of my little of my fire blob, you know, like my actual graphic, would that be part of it? Because I just realized in Photoshop, I don't have that open. In Photoshop, if I were to open the fire particle here, right, this shape, and it's super hard to tell. Let me give it a black background. Right, is sort of like a bell shaped. Where I think if we could change the shape of this, could I? In the gradient tool, can you, like, how can you tune? I mean, obviously you want radial. No, not that. I want that, but with a different fall-off pattern. Where it's like more centered to the point and then fades out more. Like more, not, where it sort of hits full value in one in the middle, but then drops off very quickly and then lingers. So it's sort of a long tail shape. I think that's it, actually. I think to get the fire effect that I'm looking for a little bit more, because it's definitely faded the edges, but it doesn't fall off quickly enough. I think what I would have to do is actually just end up with a slightly different drawn pattern and then figure out something like that. Alternatively, instead of using any graphic whatsoever, we could use something with just like a shader calculation. But that being said, I mean, it's definitely glowy. The additive part is actually working to be additive and very like glowy and shiny, and I do like that. And then if we run around, yeah. I mean, that looks bright. Like, jump in an arc. Character's on fire, yo. Especially if you tied this into more lighting effects. And that's actually one of the interesting things you can do with a additive shader. Let's say, okay, let's do something crazy here. On our fire particle, we've got a couple of fire particles over here. What I want to do is I want to create another instance in here, which is sort of like the light effect. Okay, it's going to be quite big. In fact, even larger than this, like this. It's going to render on the fire outline effect. It's going to be considerably more transparent, but it's very important that it is using the additive shader. So if we did something like this, and then I applied this, and hit play, 0, 0, like that. Apply. Okay, the additive effect is definitely source alpha. Yeah, I guess it really is adding everything together, which for this one is may not what I want. Just realizing for this light effect. I'm going to have to figure something out. Oh, not default material. Sprite default. Like, I want to make it look like there's a bit of a light effect that goes on it, but I need it to be capped and not just apply infinitely. Again, if this part were 1 and then the other thing was source out or 1 minus source alpha, this is back to our normal transparency mode. I gotta give it a think. I gotta give it a think. I mean, for now, clearly we don't do the extra light effect on there. And in fact, what I'm gonna do is I'm gonna leave in what I feel is the correct additive way. Just add one to the other. Oh, and forget that this has got to be disabled here. Yeah, convert view. There you go. It is glowy. Feel the fall off's not good, and I would like a little bit more haze. Although I guess one way to do that would be to make this even more like just bigger and super fall offy, transparent further away. Make a little bit of a lit haze, which becomes considerably more valuable on a darker background. But even then, I think to make the effect really convincing, you'd have to factor in some like normal lighting and stuff like that, because you'd only want it to light things from one side, which is probably true. Although one thing that I bet you would be pretty good is if we did take our running character, and let's say I take this fire particle, which is not very like well named. Keep this on the character layer, but give it the sprites additive over here. Make it quite a bit larger. And then make it quite a bit more diffuse. Okay, it's not actually this big. I'm realizing it's... There you go. So now our character's got a light around her. And because it's additive, it's just adding a little bit of whiteness wherever the character is. So this is like sort of a self-lit thing. There we go. Again, this won't throw any shadows or anything, so you have to be careful about that sort of stuff. But it's not a bad sort of shortcut, especially, again, if the background were very, very, very dark. So if we take all this and we make the background darker over here, now all of a sudden it's normally quite black, but wherever the character is, you can make out the details. So if the character's away, you can't tell anything from the background, but as you move closer, you can see that brick pattern. It was a really subtle brick pattern, right? So we'd want to change something. But now we've got a fake pseudo lighting effect with this additive filter, where if it wasn't additive, if it was just the regular sort of sprite default, then it's still not bad, but you might lose some of the details because it's going to average towards white, whereas this is probably a little better. I might be imagining things. It could be that I haven't done a good job with that shader at all. I'll have to re-examine it. But the fire outline stuff is cool. And that's the sort of thing I was looking for. So I know this was like very sort of seat of the pants. Like I didn't know what we were going to do going into it. I had a certain idea, spawn things around the border of an object, but sort of like learn along the way. And I hope that this was like actually, I really want to show off like the idea of, okay, so you have an idea, how do you approach it? And this is the sequence I decided to take it. I was like trying to teach that aspect of it too, right? Because I went into here not knowing exactly what I was going to do. I had a few ideas that we needed to test. And then we tested them. We saw what worked and what didn't. We iterated. But yeah, that's not a bad fire effect. And it does automatically go and border around your character. Oh, again, one of the things you could do, you could go and only spawn this fire effect, say, on the top surfaces, because it is spawning out of the bottom right now. Now, it probably is important to do that to get, like, your feet properly surrounded, because otherwise nothing would spawn down here at all. The first that would spawn would be over here, which means your feet would never be sort of encased in flames, which I think would be incorrect. But you could do it if you wanted to, and the easiest way to do it is when you do take your 2 points, you can just, you can just check the normal vector, or if you don't know how to do that, just find out like the vector from point A to point B, make that into a vector, right? It's the distance between the two things, and then rotate it 90 degrees counterclockwise. And if the resulting vector has a positive y component, then it means this is pointing up over here, right? Whereas these would be pointing downwards. I mean, the normal vector is probably the way to do it. But the 90-degree trick also works perfectly fine to give you a normal vector. So any of them where the y component would be pointing down, then that's the wrong kind of face. So that's one way to do it. You could also have particles only coming out the front or the back if you check things based on the x component of that normal vector. And so that might lead to some interesting and fun behavior with these particles as well, right? You can use, for example, these particles could be like fire coming out, or jets coming out the back of your rocket engine, right? In which case directionality would matter a bit more. Although with something like that, no, you wouldn't care about this collider the same way. Instead, you would just use it by tuning your particle behavior to have a velocity in the x direction as opposed to the y, and you would just attach this to a smaller collider, as opposed to your whole spaceship, because that wouldn't make any sense. Different purpose. But you could use this as a basis for something that would make rocket engine stuff come out the back of your ship. Anyway, so I hope you found this enjoyable. And, again, just sort of mostly goofing around. But I think it looks kind of badass. So thanks for watching. See you next time. Thank you, October patrons. Those are the people who pledged in October and who are supporting these videos from November through to early December, and especially these Mic Check supporters. We've got Yuko Finn, Adam Conway, Drazian, Jan Torrivel, Additive, Michael McClintock, Aaron Toyson, Craig Mortel, Stephen Wendell, Julien Auger-Lafont, Marius Fielvold, Speedy Savant, Valiant Cake Fiend, Wes Oldenboiving, Jason Yanity, Kale the Quick, Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you very, very much.